All right, this is for assignment 9, multiple regression, section 9.4 for Providence Stats. So again, this is assignment 9. With the multiple regression, we don't have the setup to do a lot of this, so we're going to do just a very small amount for this multiple, for this section. I'm going to show you and try to explain some of the stuff that we can't do, and just know that there's a whole lot that goes with multiple regression that we're not going to do in this class because of the technology and because of what's going on right now too. We might be able to do it if we were all here together, but being all separate, we can't. So multiple regression, all multiple regression is, or well, actually what we're going to cover using technology, and this is the part that we're not really going to do, to find multiple regression equations, the standard error of estimate and the coefficient of determination. And remember, your standard error of estimate, that's your SE, and your coefficient of determination is your R squared. We're not actually going to find those because we don't have the setup to do it. I mean, we probably do, but I'm not going to count on the fact that that everybody can do it. Be able to use multiple regression equations to predict. This is the part that we're going to do. So that's the main thing of today's lesson. And the other main part would be just to understand what a multiple regression is, how we're, what the setup is. Multiple regression equations. When we've done the regression equation, so if we got rid of multiple here, when we've done the regression equations up to this point, what we've been doing is comparing one thing to one thing, or seeing how one thing affects one outcome, all right? So some of the stuff that we did, I think one of the charts that we did at one point was students' GPA, how their GPA was affected by the hours of TV they watched. So it was TV, and then that was our independent variable, and GPA was our dependent variable, and we use those two. Well, there's a lot of other things that could go into affecting that student's GPA other than the TV that they watch. So that's what multiple regression does, is it not only takes into account how much TV did they watch, it might take into account other things like how many hours did they work at their job, what kind of education, or how many years of education did their parents obtain, so on, so on, so on. So it would take into consideration all those other things to get that one dependent variable. So it's just, when you're dealing with multiple regression, you're dealing with putting in several x's to try to figure out how they affect the dependent variable, your y, how they affect the outcome. So there's more than one thing that could go into affecting that one certain outcome. So in many instances, it's a better prediction can be found for a dependent variable by using more than one independent variable. So if we're doing more than one thing, for example, the carbon dioxide emissions that we talked about in several of the other sections might be made considerably by considering the number of cars. A better prediction might be made by considering the number of cars as well as the gross domestic product. This is all they used before for our X, and now what they're saying is you could also take in consideration the number of cars. A good example of that, if we look at the United States, where our gross domestic product is high and our carbon dioxide output is probably extremely high. So that really affects that linear regression, or how those two are related to each other. And part of the reason might be that just about everybody that's 16 or older in the country, or a high percentage, owns a car. Whereas if you look at a big industrial country like China, many more people, or a high population in China, but not everybody owns a car. So their carbon dioxide emissions might be, I can't say because I don't know for sure, but just using this as an example, might be considerably less than the United States, because there's not as many cars, not as many of these other things. So those are all things that we would could take into consideration to make it multiple regression instead of just linear regression, just dealing with one thing. And when we're doing this, it's going to be, let's go back, it's going to be where we have multiple x's, so multiple independent variables that we're looking at. So we might have like an x1, an x2, an x3, so on, however many of them we have. These are all independent variables. And we're seeing how all of these things affect that one output, that one dependent variable that we're looking at. All right, so so we're looking at that, how all those different things affect that. When we're looking at that, and I'm not really the greatest at explaining this, but what you're trying to see is how it's sort of going to be like it's three-dimensional or more, depending on how many independent variables you have, because you're trying to look at things, how one thing affects the dependent variable, how something else affects the dependent variable, and so on and so on. So when you're looking at it, you're probably looking more at a three-dimensional kind of setup, where you're looking at all kinds of different points and how they're related to each other, and we're trying to figure out how, or what the best equation is that we can predict off of in that three-dimensional setup, or it could even be, if we're taking more independent variables, and that could be even more than that. So I'm not good at the idea of picturing it, because I don't have much imagination. So, but as far as a chart goes, that sort of makes more sense to me, and that's what I was just saying with this chart. We're looking at a whole bunch of different independent variables, however many of them we have, and we're saying, how do these affect the outcome, what we're trying to get out? So with the GPA stuff, how many hours of TV does the student watch per week? If they have a job, how many hours do they work per week? If they have other things, maybe their parents, again, their parents' level of education, so on, how many siblings do they have? All those different things could be things that affect their GPA. So all those things would be our independent variables, and then we're trying to see how they affect that. And we can do all the same stuff with this multiple regression that we were doing with the other stuff, and that's using the R squared, the coefficient of determination, to see how well it actually does fit that regression, using, if we go back here, using the error of estimate, the standard error of estimate, to help us decide how well is this really predicting what our Y value should be. Again, all we're gonna do, we're not gonna do all of this, and I'm gonna explain why here in a minute. We're not gonna do all this, we're just gonna do, given an equation, a multiple regression equation, given that equation, and making some predictions, what y should be from those equations. Just some things to explain multiple regression to you. There are three major uses for multiple linear regression analysis. First, it might be used to identify the strength of the effect that the independent variable has on the dependent variable. So how much does that independent variable affect the actual outcome, the dependent variable? Second, and again, the linear regression was the same thing, but now if we put more factors in there, more things in there, we can maybe be a little more precise about how all those things together affect that dependent variable. Second, it can be used to forecast the effects and impacts of changes. So as something is changing, how does that affect or impact the outcome? How does that affect our dependent variable? Multiple linear regression analysis helps us to understand how much will the dependent variable change when we change the independent variables. For example, a multiple linear regression can tell you how much GPA is expected to increase or decrease for every 1 point increase or decrease in IQ, or this again goes back to the stuff, you know, IQ, how many hours of TV you watch, so on, so on, so on. Third, the multiple linear regression analysis predicts trends and future values. So we can look at this stuff and see how things are going and see what's going to, what the trends are going to be, so that we can predict what's going to happen in the future. Right now would be a good time of that if we're looking at all the different things going on in our world right now and figuring out trends and future values in like the stock market or of gold prices or of silver prices. This is the way that a lot of the experts make predictions off of this stuff. The multiple linear regression analysis can be used to get some point of estimate. An example question may be, what will the price of gold be 6 months from now? So I'm not sure what the price of gold is. I'm not somebody who's real big into putting a bunch of money in the stock market and all that stuff and gold prices and all that, but I know the stock market right now is really taking a big hit. So as it's taking a hit, if you expect that our country is going to come back from this, now might be a good time to buy up stuff, because if you're buying it right now and prices are really low and you expect that our country is going to completely come back from everything that's going on, then in a year or 2 or 6 months or 8 months, when everything straightens back out, the prices will be back up, and so you could make some money. Again, I'm not sure what the price of gold is, but if gold prices are down right now, because they've been so high for so long, if they're down right now, it might be a good time to buy up a bunch of gold, and then in a year or 2, if the prices are way back up, to sell it off. And we could make those predictions by using this multiple linear regression, by looking at different things and predicting what's going to happen. An example, imagine that you're a traffic planner in your city and you need to estimate the average commute time of drivers going from the east side of the city to the west side. You don't know how long it takes on average, but you do know that it will depend on a number of factors. A number of different things are going to be included in there. All right. So we don't want to make a prediction just off of, you know, saying, all right, they got to drive this many miles. How long is it going to take? So miles compared to time, because That's a nice, easy, linear regression that we could use, but there's more factors than just the number of miles to take into consideration there. Some things, that depends on the mileage, of course, the number of stoplights in their route, the number of other cars on the road, that might be, you know, the time of day, so on, depending on that. The day of the week, all those things are factors that would go into how much time is it gonna take somebody to drive from the east side to the west side. Other things, construction, different, you know, road constructions, all that stuff might come into consideration there. So those all would be independent variables that we could maybe take into consideration to figure out our dependent variable. Another example, the yield of rice per acre depends on quality of the seed, fertility of soil. I know we don't grow much rice around here. You could stick, instead of rice there, you could stick in corn or soybeans there if you wanted. Fertility of the soil, fertilizer used, the temperature, the rainfall, how, you know, all the different things could go into effect what the yield is going to be for that certain year. So all these people who talk about farmers and, you know, say that all they're doing is planting stuff and hoping it grows and all this. If you're a good farmer, you've got to take into consideration all of this different stuff to decide, hey, what is my yield going to be here? And a lot of the farmers around here, that's why you see them from one year to the next. You know, they might plant, and I'm not sure because I'm not a farmer, but they might plant corn for 2 straight years, and then they plant soybeans. And then corn for 2 straight years, and they do that because the yield, what the corn needs in the ground and what the soybeans need in the ground are different things. So they do that, alternate that stuff to get a better yield. If one is interested to study the joint effect of all these variables on rice yield, one can use this technique. An additional advantage of this technique is it also enables us to study the individual influence of these variables on the yield. So, you know, decide how much does the quality of seed really affect it. You know, if you're dealing with something, you're planting this rice, and one kind of seed is $50 for 100 pounds, and another kind of seed is $10 per 100 pound, is that money really worth that higher quality seed? So how does each one of these influence that? The fertilizer used, you know, if you use one fertilizer or another fertilizer, how does that affect your yield? You know, if you're paying a whole bunch of money for some fertilizer that's supposed to be great, is it giving you a better enough yield to take that, paying that extra money for the fertilizer? So those are all variables that we could come into. Again, the main thing here is multiple regression is we're looking at multiple items, multiple variables, multiple independent variables that affect the outcome, the Y or the dependent variable. A multiple regression equation looks like this. That's what a multiple regression equation looks like. It's still the y hat. And then B is your y-intercept plus, it's a plus, slope of your first linear regression line, of your x1, slope of your second regression line times x2 plus the slope of your third regression line, x3, so on, so on, so on, all the way out as far as you want it to go. That's what a linear regression line looks like. All these x's, all these different x's here are just the different things that we're going to take into consideration here. So maybe we are looking at the rice. Maybe we're looking at the fertilizer that you used, the temperature it was, the average temperature for the last month, how good the ground is, the seed that we used, the quality of it, so on, so on, so on, and then we want our yield out here. So all of these things are independent variables, and this is our dependent. How are they affecting that yield, that outcome? B is the y-intercept. So that's where, and I'm not exactly for sure here because I've read different things and learned different things, but this is where I think we sort of like put all these lines together and decide where about they're going to cross that y-axis at. Y is your dependent variable. That's what we're trying to get out. Because the mathematics, I'm going to erase this. Because the mathematics associated with this concept is very complicated, it's almost always use technology to calculate multiple regression equations. All right? And some things that we're going to do, or I'm going to explain here. Are just the different ideas that we could use, different technologies that we could use to do all this stuff. The first one is what our book uses. And it's Minitab. And I was lazy and I never have went online and bought the Minitab setup for the book in the years that I've been teaching this, but I'm sure you could probably go online and get the Minitab setup, and that's probably the easiest one because it just has a basic good setup to figure out multiple regression equations and the different stuff that goes along with multiple regressions. So that's one. The second thing is our calculators, if we use a TI-83 or 84. Now the bad thing with the TI-83 or 84, it doesn't have a setup on there, otherwise we would be doing some of this. It doesn't have a setup for multiple regression, but it's still possible to do it on there. There are programs or apps that if you get online, you can find an app to download it. I seen a couple of them as I was looking. You can download these apps, and then your TI-83 or 84 will do the multiple regression. The bad thing is I didn't find any. I didn't find any that I could just download for the 83 or 84. Most of them were for the TI Inspire or the TI-89. So they were for the higher level calculators. The other thing on the TI-83 or 84 you can do, if you put all of your X's, so X1, X2, X3, however many of them you have, into the list, and then at the end you put Y, all your Y's into a list. So you put all these into the list on your calculator. And then what you have to do is you have to convert each of those lists to a matrix. Hopefully, most of you remember what a matrix is. You've seen it in your other math classes. So, it's going to be converted into like a matrix where it's going to be 5, 6, 7, whatever, 8, 9, 10, 11, 12, 13. It's going to be converted, and there's a button on your calculator. If you go to second and you go to the X to the negative first button, right above it, it says matrix. Maybe you use that button in some of your other math classes. And then you go over to math, and then down to this, it says list, and then it's got an arrow, matrix. So that's just converting. So the calculator will convert each of your lists. You just have to do them one at a time. It'll convert each one of these into a matrix. And then one other thing you have to do is and I'm not going through all of this because we're not actually going to do it, just trying to give you an idea of how it's possible. Then you go in and you also have to create a separate matrix that has all ones in it, that's the same size as list 1, list 2. And once you have all that, then you can start to do all this stuff. And again, it goes into a whole lot more detail than that, so it's a lot harder if you could just find the app. And it'd probably be easier. I've seen one app that actually looked like an app that like Mr. Alexander would have made that was written out. It'd probably be easier to type that app in to your calculator than going through and doing this every time. Third way that we could do multiple regression is using an Excel spreadsheet. You could just copy and paste all of your X's and all your Y's into an Excel spreadsheet. The bad thing with that is you have to have the correct version of Excel. So there's a certain version, and here at school we don't have that version. So, but if you have maybe a newer version of Excel or a better version of Excel than what we have here at school, it's possible to do them on there. Just going through this example just real quick, just to give you some idea about this stuff. Again, we're not going to write or come up with these equations ourselves. We're just going to make predictions. This one you'll notice, this book uses the Minitab. A researcher wants to determine how employee salaries at a certain company are related to the length of employment. So that's our first variable. Previous experience, that's our second variable. And then our third variable is education. So they're looking at how their salaries are related to this. So the salary is like our Y, that's our dependent variable, what our outcome is, and the other three are our independent variables. The researcher selects 8 employees from the company and obtains the data shown on the next slide. Use Minitab to find a multiple regression equation that models the data. Again, we don't have Minitab, so I'm going to show you the chart and everything here. So they collected all this, their salary. Notice that they sort of got these backwards this time. This is our dependent variable. A lot of times they'll write them backwards, sometimes they won't. It just depends on who's doing it. These are our independent variables. So we're saying, how do all these things affect that dependent, the salary? It's telling us how to do it. That when we're putting it in Minitab, this is what it would look like in Minitab. So it tells you your y-intercept, first slope, second slope, third slope. And when we write our regression equation, it would look like this. Remember, your b comes first, then you got your slope of your first regression line, x1 there, slope of the second one, slope of the third one, so on and so on. So that's our regression line. It's just putting a little more in to what we've been doing. It's adding on more things there. After finding the equation of multiple regression line, you can use the equation to predict y values over the range of data. This is what we're going to do. So we're going to predict. We're going to let them give us the equation. Sorry, I took you through all that for 30 minutes. We're going to let them give us the equation and predict off of that. To predict y values, substitute in the given value for each independent variable into the equation and calculate your y hat. Remember, your y hat's your predicted value. Use a regression line to predict off of this. So we got this regression equation to predict. So we're going to use this and we're going to predict what the salary would be for a person that has the given information that they're telling us here. 12 years of employment. So that's going to go in right here for our X1. 5 years of experience, that goes in here for X2, and 16 years of education, that goes in here for 3. We're just going to plug those in. We're going to do all that math, and that's going to be our prediction. And when we make these predictions with this multiple regression equation, it's going to be a little more precise than it would be if we just had, if we got rid of this part and just had the one variable that we were predicting off of. So we stick all those in, and we can predict that if an employee comes in with, or if an employee has worked for us for 12 years, they had 5 years of experience before that and 16 years of education, that they should be making about $59,544 per year. If we wanted to make another prediction off of this, maybe we got an employee that's worked for us for 4 years, or worked for this company for 4 years. They had, before they came to our company, they had 10 years of experience maybe. And maybe they only had 12 years of education. Maybe all they did was they graduated high school. Then we just plug in here. For X1 right here, we plug in 4. For X2, we plug in 10. And for X3, we plug in 12. And all we're going to do, you can punch all this into your calculator just like that and make that prediction. That's going to be your y hat. So if we plugged all that in, 49,764 plus 364 times 4 plus 228 times 10 plus 267 times 12, it's going to tell us about how much that employee should be making at this time. So be able to use the technology, again, we're not doing that. All we're going to do, predicting the y values. The 9th assignment here is on page 527. And we're going to do, it shouldn't be real hard, each one's got like 4 parts, but they're not real hard because all you're doing is plug them into the calculator. Each one's got like a A, B, C, and D. All we're gonna do is problems 1 through 4. So page 527, problems 1 through 4.